Okay, so again, we're going to keep looking at a reaction, again, just between two particles. We're going to again look at particle A reacting, as we've done before, with particle B. But this time, we're not going to change the concentration. We're not going to change the surface area. We'll imagine that these are two gases reacting together. And we're just going to keep A and B the same. And again, we're going to allow them to collide. So again, we have to allow collision to occur. Without a collision occurring, a reaction can't possibly occur. And so if we have a collision between A and B, then there is a possibility for a successful reaction to occur and particle C, for example, to be produced. Now, there's a number of ways in which temperature can affect this reaction. If we think of a simplistic way in which the particles move, if we increase the temperature of the particles, the reaction vessel, then both of these particles are going to increase in energy. So if we increase the temperature of a substance, then what we assume, therefore, is that the energy of the substance is also increasing. What that's going to do is increase the speed of the particle motion. Okay, so if a particle is moving faster, it's possible, if we look at this diagrammatically, it's possible that if particle A was moving at a certain speed, it could hit particle B within, say, 1 second. If we increased the speed of particle A, though, and likewise particle B, I suppose, then it's possible that if A was moving, say, twice as fast, then it is possible for A to cover more distance in a very simplistic fashion. So at a lower temperature, it was possible for A to hit B, say, once in a second. But if we increase the temperature of the particles and allowed A to move faster, then A could have come into contact with 2 lots of B, because it could have covered more ground. So it could have collided with the first particle of B, not necessarily reacted, because remember, these is the probability of a reaction occurring. So it could have collided with the particle B, not reacted, but then carried on, and within the same time frame as the previous experiment at a lower temperature, being able to collide with a second particle of B. What that does is increases, as we've done before, increases the number of collisions, or increases the number of potential collisions, and therefore, as a result, increases the probability of a rate being increased as well. Okay, so by increasing the temperature, we've increased the speed of the particles, we've increased the energy of the particles. So what that's allowed us to do is increase the possible number of collisions, and subsequently allowed us to increase the possible number of successful collisions, and subsequently the rate has increased. Now, there's also another way in which temperature can do by looking directly at energy, and we're going to look at that when we look at catalysis in the next clip.